This is a video on using the method of discs and washers to find volumes. The question is, find the volume of the solid generated by revolving the region bounded by the graphs of y equals 1 minus x and y equals x squared minus 5x plus 4 about the x-axis. Notice that the y equals 1 minus x is a line and y equals x squared minus 5x plus 4 is a parabola. My first step is to graph these two, and I used a computer to do that. You can do it by hand or by calculator or computer. And what I get is, again, the parabola and the line. And notice that the parabola is below the line for this region. What I'm going to do next is draw a cross-section. That means draw a little vertical line segment from the top curve to the bottom curve. And there it is. And then I'm going to revolve the cross-section about the x-axis. And one technique is to take that cross-section, just that little piece, and first just reflect it up here about the same distance above the x-axis, like so. Then I'm going to take the inner dot here and the inner dot here and connect them with an oval, like so. And then after doing that, I'm going to take the outer dot and connect them with an oval, and that will give me a washer, as we can see. I'm going to shade it in, and there's our pretty washer. I like to set it aside, put it next to it, and really highlight that I have a washer. And with the washer, I have an area, is the area of the larger circle minus the area of the smaller circle. Or in other words, pi times capital R squared minus little r squared, where capital R is the larger radius and little r is the smaller radius. For the smaller radius, that's going to be the distance from the x-axis to the line. And that is negative r, in that case, will be that coordinate here, which is 1 minus x. And notice since we're squaring, the negative goes away. And then for the capital R, that's going to be the distance from the x-axis to the parabola. And x squared minus 5x plus 4 will be negative r. Since we're squaring, the negative goes away. It's just a technicality. So now I'm going to find the total area. And what we get is that the area is equal to pi r squared minus r squared, or pi times the larger radius squared minus the smaller radius squared. So finally, I want the volume. And remember, the volume is the integral of the area. And the limits, the intersection here is at 1, x equals 1, and the curves intersect here at x equals 3. So what I'm going to do next is I'm going to integrate. So I'm going to integrate the integral from 1 to 3 times pi of, again, the larger radius squared minus the smaller radius squared dx. And I worked that out. I could do it by hand. I used a calculator, actually. And what I get when I do that is 11.72. And that's the volume of my region when you revolve it around the x-axis. And I'm finished with the problem.